Hi, Keith Van Wimmer, VanTek Consulting. Welcome to the VanTek channel. If you are a first-time visitor, welcome. Always glad to have new visitors. If you're a subscriber, thank you for subscribing. We appreciate your support. Today we're going to expand. We did a review on this guy. This is a BondingBuddy, and he is a meter agnostic far end device. So he can strap your pair for you, he can open the pair, and it kind of helps us, on the far end. It helps us so we're not going back and forth. So we have remote control from the near end, where our meter is, and we can control the testing conditions, so to speak. What we're going to do today is there's a full review on this guy. It's a little lengthy, but pretty thorough. And full review on him. So I'll put a card up here on the up in the corner for you guys to pop over to if you want to view that. What we're going to do is show you how this guy can actually help you in doing more advanced testing, such as resistive fault locating. I figured since I had it, we might as well go through it. So we're using a legacy meter. This is the Dynatel 965 DSP, and this guy here is still a viable meter. He's not the fastest one in the world, but it is a giga-ohm meter, has all the tests that we need to do. You're not going to get VDSL2 train-ups on this and stuff, but for your copper testing, this is still a great meter. Okay, so we're going to hook up our BondingBuddy and go out to the far end. We'll hook up our meter. We put our wand over here just by our lead so we can hear the BondingBuddy. It signals us or tells us what state it's in by these tones. So right now it's in a normal state. There's going to be some, you can't test in this configuration, because if we do, we're going to get some voltage on there, and that's what's, the voltage that's providing or supplying the tone. So we can see we're getting DC voltage over here, which is not good. So let's go ahead, and what we're going to do is we're going to short this for 5 seconds. And when you short it, the tones will go away. We'll wait for our 5 seconds, open this up, and you hear it going, I believe they call this the uptone. And so you can hear it going from lower to higher, and it is changing state and giving us a warning. If you look at our meter, we had voltage here, and now we're down to no voltage. So the pair's open. It's going to remain open for 60 seconds. So let's flip this over to our tip side. Tip to ground, no voltage, and our ring side, we have 7.4 volts of DC. All right, so this means that we have to stop. We can't do any more testing on this. If there's voltage on the line, it's going to skew any other tests, ohms, whatever. We need to stop. We now know that we have cross battery or foreign voltage on the pair. So we need to locate that. Now we can go through 5 or 6 terminals and try to figure out where that voltage is and what's touching what. Or we can use what's called a resistive fault locate. And you would do cross battery the same way that you would do a resistive fault. So you hear the tone goes back on, it's gone back into the normal state. We need to go into our RFL function. So we have our faulted conductor, which is red, our good conductor, which is green, and our black conductor, which is the other side of the fault. So the traditional method or hookup of an RFL in the older meters was red was bad, green good, black to the other side of the bad, right, to the other side of the fault. The newer meters, if you're running an Onyx or HST 3000, the HST 3000 can go in this configuration, or it can go in the modern configuration, which is black is good, red's bad, green to ground, or other side of the fault, okay? HST will go either way. You can swap it in firmware, but for now we're just going to stick with this. They all have a picture on them. So again, this has a key on the side. So what we need to do is we need to put a strap at the far end. One issue with a FED is that this guy can't be connected. The ground can't. So what we have to do is we have to pull that. So unfortunately, we're going to go down to the far end and we're going to disconnect that. Remember, the ring was the bad, so we're going to put the ring on the bad. Our tip was good, which gets the green conductor, or green clip. And don't think of these as tip ring ground anymore. And then the black goes to the other side of the fault, which is the ground. All right, once we have that, you want to verify on your meter that your gauge and temperature is set as accurately as possible because these do influence the resistance, and this is doing a calculation based on how many ohms per foot for 24 gauge, etc. So again, that temperature does impact your readings. For typical troubleshooting, if we can get this close enough to figure out which pedestal it's in or which terminal, 1248, whatever, we're good. All right, that's as close as we need to get. But you can get this guy pretty accurate. So now that we've got everything hooked up, the far end is on. Let's turn on our little beeping again. We need to short this tip and ring or the strap for 10 seconds. And now you get, again, what I believe they call the down tone. So you can hear it going downwards, all right, in frequency. It's now strapped, so we're ready to go. We will hit our enter to have it start its resistive fault locate test. And this uses, if you want to do research on it, this uses what's called a Wheatstone bridge, and it measures one direction, then it measures back the other direction, and measures back through the fault, all this wonderful fun stuff. It does some really cool calculations, and then it gives us a distance. So this first number we see is 1957. So 1957, this box we know is 1,920 feet. So again, 24, this is Cat 5, so 24 gauge, 76 degrees, we're close. Again, 1957 is distance to strap. So some meters you'll see DTS, and that's distance to strap. So that's a distance from this end over to this end of the box. The next number is 1935, which is distance to fault. Okay, so from this end, it measured from here down to the strap, and the fault is at 1,935 feet. That last number, 22 feet, is distance strap to fault. So that fault is sitting down at this end, 22 feet of our fed. Now we're going to go back down there, go 22 feet from here, and so our cross battery basically on the box says it's right at this end. But again, it's, there's some copper in here. So it's 22 feet from here. We'd go to that workout terminal, remove the battery. We could rehook this into the normal state. The pair is now fixed. We go back. We get everything back on here. And then we go back through, set our open. So 5 seconds, uptone, and as soon as our uptone goes off, the pair is now open, so now we can go back through our testing. So we got 0 volts on our tip to ground, we got 0 volts across tip ring, and we've got 0 volts on our ring. So now that we're clean, we can move forward, go to our ohms. Again, we're looking for 999, 999 there, 999 on the tip side, tip to ground, and then finally 999 on our ring to ground. Don't forget, whenever you do a repair on the pair, so in this situation where you remove the cross battery, always go through your testing again, because some faults can hide other faults. Okay, so let's go ahead, look at our open. We're 1525 on our tip to ground. We are 1526 on our ring to ground, so that's fluctuating a little bit. 1528, and that's within our 1%, and 1727. Again, this is because of air core. We've done everything that we need to do. We could go in and test our longitudinal balance and all that fun stuff, but again, mostly the resistive fault locate is what we want to demonstrate on this. So just remember, set the meter correctly. Make sure when you do your strap, you strap good conductor to faulted conductor. Once you have that, make sure you take the ground off so that you'll get a good strap. This guy is the only solution I know of on the market right now that allows you to utilize a Fed with legacy meters, with modern meters, with they're brand agnostic, so with basically any meter that's out there that you're using to test copper with. So this is a pretty good little guy, and I got to tell you, the people up there, the folks up there at BondingBuddy at Pine River Innovations, Great people, great folks, real friendly, always happy to help. So give them a shout. Go check it out. Visit the website if you want more information. Give them a call. Good people to talk with. Anyway, that's it. I hope you found the video useful. If you'd like to see other videos like this, or on anything that has to do with fiber, copper, fiber splicing, copper splicing, etc., feel free to leave us a comment down below. We're always happy to hear from you folks. Give us a thumbs up. If you're not subscribed, we would appreciate you considering subscribing to the channel. It always helps, and we love the support. Anyway, until next time, you folks be safe, and we'll see you on the next video. Thanks for watching.